for our turbine setup, we start with the power supply. So it first sends signal to the PLC, or first sends power to the PLC and this node as well, because this doesn't have power, so we have to supply it with power, so it runs the 24 volt and the 0 volt. We then have it running a current signal out of channel 1 to the PCD, which then supplies a current, as you can see on the screen right there, to the control valve to adjust the valve open or closed, which is supplied from the PLC itself. So then we have our pressure regulator, which you usually have set at around 90 psi. We can supply it 100, but we don't see a reason because it hits the goal that we need it to, so we just keep it set at around 90. So then this then supplies air through here into our turbine, which spins. We covered up these exhaust ports back here. We were losing a little bit too much air. So instead of reprinting this whole piece, we just decided to tape it up so it sends more air out the front, which in turn makes it spin more efficiently. We did tape this here. This is liquid tape. This is just something we found in our lab. We taped it all the way around on both sides. We were losing a little bit of air through here where they got a little hot during printing and warped. So we just aren't losing any air through there anymore, and it's able to come out through the front. We then have our turbine spin here, which is picked up by the sensor, which sends a voltage signal to the Arduino. This Arduino sends a 0 to 5 volt signal back to the PLC using pulse width modulation because it can only send an on and off signal. And this is our diagram.
Demonstrating the Tesla turbine disturbance with PID control. So I'm going to add a disturbance to the shaft with my finger. And then it's going to correct itself. Disturbance. And now we are going to change the set point and watch it adjust to the set point. And we're going to take it to a different set point. So how we found our proportional, integral, and derivative gains were, first the proportional gain. I ended up with a KU of 15 because when I had it on 15, it wasn't hitting the upper or lower limits for the output in bias. So, and then for our period time, we ended up going with how many cycles were in the output in bias graph. And then we saw 2 cycles. So it was 2 cycles over a period of 12 seconds. So we did period of 24 seconds divided by 2 cycles gave us 12. And to actually determine our proportional, integral, and derivative gains, we had to look at Nichols' little chart and divide it by the appropriate numbers based on if we're using a proportional, only proportional, or proportional integral, or all 3. So we had to use the one with all 3 because we are using proportional, integral, and derivative. So 15 was divided by 1.7, 12 was divided by 2, and 12 was divided by 8. And our gains are inputted right here.